Hello friend, first of all thank you for giving me this opportunity. I am introducing myself. My name is Punam Khillari. I am studying in B.Sc. second year from Adarsh College Hingoli under SRTM University Nanded. So friends, welcome to this online seminar session. So friends, let's move to our definition. Convergence of improper integral. Let a function f be defined in an interval closed interval a comma b everywhere except possible at finite number of points. Convergence at left end. Let a be the only point of infinite discontinuity at f, so that the integration of f between the limit a plus lambda to b exists for every x. O is less than lambda, lambda is less than b minus a. The improper integration of f between the limit a to b is defined as the limit of integration of f between the limit a plus lambda to b when lambda tends to 0, or integration of f between the limit a to b is equal to limit integration of f between the limit a plus lambda to b. If this limit exists and is finite, the improper integration of f between the limit a to b is said to be exist for converge at a. If otherwise, it is called divergent. Convergence at the right end. Let b be the only point of infinity discontinuity of f. The improper integral is defined by the relation integration of f between the limit a to b is equal to limit integration of f between the limit a to b minus mu 0 is less than mu is less than b minus a. If the limit exists, the improper integral is said to be convergence at b. Otherwise, it is divergent. Convergence at both ends. If the endpoint a and b are the only points of infinite discontinuity of f, then for any point c within the interval closed interval a comma b, the improper integration of f between the limit a to b is understood to mean integration of f between the limit a to c plus integration of f between the limit c to b. This is equation number 1. If both the integrals in 3 exist, the improper integral convergence. Otherwise, it is divergent. We also define it as integration of f between the limit a plus lambda to b minus mu. The improper integral exists if the limit exists. Convergence at interior point. If an interior point c, a is less than c, c is less than b is the only point of infinite discontinuity of f, we put integration of f between the limit a to b is equal to integration of f between the limit a to c plus integration of f between the limit c to b. The improper integration of f between the limit a to b is convergent if both the integral on the RHS exist. Similarly, if the function has a finite number of points of infinite discontinuity c1, c2 up to cn in closed interval a comma b, where a is less than or equal to c1, c1 is less than c2, c2 is less than up to cn, cn is less than equal to b. The improper integration of f between the limit a to b is defined as integration of f between the limit a to b is equal to integration of f between the limit a to c1 plus integration of f between the limit c1 to c2 plus up to integration of f between the limit cn to b, and is said to be convergent if all the integral from the RHS is convergent. Otherwise, it is divergent. Thank you.